we're going. Okay. All right. Yeah, like a lot of class participation here, and hopefully a few more will show up. 20 years ago, 20 years and 2 months ago today, it happens to fall on, was an electrical event here in Arizona. Does anybody, we're all old enough, if we were in Arizona, to remember when there was a problem with a circuit breaker somewhere in Northern California, and it caused the power to go out there and caused a domino effect across the Mountain West and Southwest, and much of the western region of the United States was without power for up to 12 hours for some areas, if we remember that. August 9th, 1996. So then about 5 years ago, the transformer fire out there at University and Power Road. Much of Mesa was dark for 6, 7, 8 hours, and both were hot summertime weather. And so that's what this is kind of about. You know, we talk about natural disasters, and the biggest potential for disaster in Arizona is a massive, lengthy power outage, especially in the summertime. And so that's what this is going to be about, is ways to provide essential electrical needs in your home. And this is all good stuff to use for going out camping and that sort of thing also. Let's talk about the basics of electricity, just so if I say a term, and everybody's heard these terms before, but in case you haven't fully understood what they are, we'll kind of go into it. And if there's a question, please ask. Everyone's heard the terms volts and amps and watts, and also watt hours. A volt is the pressure of electricity, like what you see putting your, where's my pointer there, putting your thumb over the hose and feel the pressure. That's electrical voltage. Whoops. Current is the flow of water, the gallons per minute of water going through the hose there. That is your current. That is amps. And watts is the work being done. I wish I had a picture of somebody spraying rocks down a driveway, because the rocks flowing down the driveway is work being done, the equivalent of electrical watts. Watt hours is that amount of work over time. When you buy electricity from the power company, you buy power in watt hours. That's the units that you buy electricity in, is in watt hours. 1 watt for 1 hour of time is 1 watt hour. 100 watts for 1 hour. Thank you. It was 100 watt hours, et cetera, et cetera, et cetera. Divide it up the other way too. Keep it even. 60 watts, since there's 60 seconds in a minute. 60 watts for 1 minute would be that fraction of an hour. And you can go, I'm not thinking straight here while we're recording this either. Maybe we can edit this part. Go backwards. 1,000 watts for an hour, or 1 watt for 1,000 hours. That's what I've been trying to say, is 1 watt hour, if that makes sense. Okay. Any questions on that? 'Cause I may not have done a very good job explaining that one. Go ahead.
So there's a relationship, though, between volts and watts and...
Yeah. Oh.
Isn't there a relationship between volts and watts and amps?
Yes. Voltage times current is wattage. Voltage times amps is wattage. That is correct. 100 volts times 1 amp is 100 watts. And if that 100 watt load was to run for 1 hour, then you would have 100 watt hours of work done. Okay, the electrical grid in the U.S., this is just gee whiz trivial information here for those that might be interested. The United States is divided up into 3 electrical grids: the eastern, the western, and Texas. The majority of Texas, except for West Texas, has their own grid. There's 1 or 2 points in the country where the grids connect together, but the connection is not enough of a connection that, like, the eastern grid could help support the western grid significantly if the western grid went down. And thus, like the outage here in California, the outage in Arizona 20 years ago affected the western grid only. I remember I was a little kid, I was 13 years old in 1965. There was a big power outage in the northeastern part of the country somewhere. And being an electrical geek as a kid, I remember watching that on the news when that happened. It took the northeastern part of the country down. I think some people were down for several days. And it was a mishap of some sort in the grid back there. And then I believe not too long ago, not too many years ago, there was something up in Canada that took down a decent part of the northeastern United States. And then again, the deals that we've had here in the West. So, what are our essential electrical needs? We all have the basics, and some of our needs might differ a little bit. We all need lighting. This is the big one, and we're going to elaborate a lot on refrigerators. So please ask questions there.
Are freezers included?
Freezers are included. Yes, they are. Absolutely. We all need to cook or heat or nuke or warm up things. And we'll go into a lot more detail with that. Then for ham radio operators, there's communication, and then for other folks and other radio services, there are our communication needs. Does everyone know what HVAC stands for? Heating, ventilation, and air conditioning. So when I refer to a unit as a HVAC unit, it's an air conditioner. Air conditioner heat pump unit, which most of us have on our homes. We'll talk about evaporative cooling a little bit also. And then we have our communication, news, email, entertainment needs, computing needs, etc. And then for some of us, we have medical needs. And for those that have the medical needs, sometimes that medical need, especially if it's an oxygen generator, that's the highest priority of them all, depending on the individual. So we have lighting, refrigerators, cooking, communications, HVAC, news and information, and medical equipment. And you could probably think of a couple of more here and there for certain people's needs. Okay, let's talk about generators. We'll focus on generators somewhat here. And this is where knowing volts, amps, and watts comes into play some. If your continuous load is going to be much over a kilowatt or 1,000 watts, and what I mean by continuous, meaning half hour, hour, or longer. If it's a matter of a minute, 10 minutes, whatever, we'll get into this when we're talking about inverters and vehicles and smaller generators, or inverters and vehicles. And we'll go into the whys. But for a round number, if the load's going to be over a kilowatt for a lengthy period of time, you're going to need a generator. Generators come in all different sizes, and there are 4 basic fuels that power them. Generators need maintenance, and that's the big thing you want to toss around in your head when you think about buying a generator. They do require maintenance. You have to be a little tiny bit mechanically savvy at the least to properly own and maintain a generator. You don't maintain it, it's not going to run, or chances are good it's not going to run when you need it the most. And maintenance is, number one, running it periodically. Start it up once a month, put a load on it, let it run for 20 minutes. They like that. It's healthy for them. And it lets you know that it's going to be reliable, it's going to run. If you aren't going to run it for a long period of time, if it runs on gasoline, you got to make sure that you run it completely out of fuel. Otherwise, your fuel system can plug up and it may not start for you. And then the spark plug issues and everything else is concerned with that. So generators do need maintenance. And then we talked about gasoline for a minute. The big advantage of gasoline is it is the most plentiful fuel out there. You can get it anywhere. You can buy it anywhere. If the gas stations are out or closed or the electrical power is out and their pumps don't run, you can siphon it. You can pour it out of storage tanks. It's out there everywhere. It's easy to get, easy to use. The only bad issue with it is the safety hazard around sparks and open flames. And of course, the fact that you can't let it sit for a long period of time. It will go bad and it can gum up your fuel system. Diesel fuel is a much better choice. It's almost as readily available as gasoline. You have virtually no fire spark hazard with diesel fuel like you do with gasoline. It'll burn, but it won't flash. You know, it'll slowly burn. Burns like if you throw a match on a puddle of diesel fuel on a cold day, the match will go out. A hot day, it might light like charcoal lighter, and all. So much safer to be around. You can pour it out of a can, which is very convenient, or you can siphon it. You can easily pump it, which makes it very, very easy to deal with, and a fuel that you might want to use. Also, you can store it for much, much longer periods of time than gasoline. I personally have stored diesel fuel for over 5 years in a full container and no problem. Ran just perfect, no problem whatsoever. You got to keep it dry. That's the big secret, is keeping it dry. Diesel forms algae in it, but it has to have moisture in it for the algae to form. And having it in less than a full container and have condensation over the winter months and that sort of thing, that's what typically triggers that. Propane and natural gas. They're the fuels that you can store it forever. You never have to worry about it going bad on you. It will last forever. Its availability, nothing like diesel and gasoline. I mean, it's readily available, but you're not going to find it on every street corner, and not everybody's going to have some of it at their home like you will find diesel fuel and gasoline. Also, it cannot be poured. So you don't have the ease of pouring it to fill a tank with. You can pressure equalize it, or you can pump it, but still special equipment, safety precautions and whatnot are needed to transfer propane. Natural gas, a lot of people buy natural gas central generators for their house, and I can't understand why anyone would want a natural gas generator. What if there's an earthquake, a terrorist attack, or whatever, and the natural gas grid is shut down? There goes your generator. Natural gas is good if you can have liquid natural gas on your property or compressed natural gas on your property, so you do have fuel should the gas grid go down. And also, a lot of natural gas generators are very easy to switch back and forth between propane and natural gas. In fact, you can buy carburetors that you can switch between gasoline, propane, and natural gas, and
That was my question.
get the best of all worlds there.
So, yeah, we just bought a volcano stove, and it uses all three
Uh-huh.
types of fuel.
Uh-huh.
So it's kind of nice to have that.
Yes, whatever fuel you have is, there you go. That's it. So yeah, with that carburetor, then you can burn anything except diesel fuel. Questions about fuel and generators?
Well, okay, natural gas, we all have in our homes, most of us.
We do.
Okay, natural gas is there, and if you have natural gas feeding a generator, then you're okay. Lots of times electrical lights go out, but gas still comes in. And then if you have natural gas and propane, those two, if they shut off the natural gas, and you can go out to your propane tank and run your generator.
That's what I was just saying. As long as your carburetor can be adjusted for both and many of them can. So, absolutely.
It's the same engine, it's the same engine.
Same engine, you just adjust the carburetor to burn the different fuels. You got to make sure you get the engine with the carburetor on it that does that, if you do.
What's the easiest way if you have a generator that does both propane and gasoline? How do you adapt it so it runs on natural gas as well?
You have to get one that'll run on propane and natural gas, and there's an adjustment on it for it.
Okay, so it has to come, all of it. Because I've seen online where you could get kits to adapt propane ones to do natural gas.
I should say adjustment or adapters, depending on the carburetor.
Okay.
And I'm going to say you're right. You find more adapters than you find adjustments. But I've seen both over the years. Here's a mid-sized diesel generator. This is big enough to power a house, a typical residence in the valley here. This will power a quantity of two 3-ton air conditioners simultaneously, plus 2 other large appliances such as a water heater and a clothes dryer, plus all the essential lighting in the house, including some smaller kitchen appliances and that sort of thing. It's pretty much normal operation of the house unless you want that third large appliance. Like if the water heater's on and the clothes dryer's on, both air conditioners are running, and you want to turn on the oven, you may have to shed some load before you turn off an air conditioner, or let the water heater thermostat shut it off or whatever. And then so that'll pretty much run a house, or a house that just has a single 3-ton air conditioner on it. It'll run the whole house hands down, no problem, unless you have some additional large appliance of some sort there.
Doug,
Yes.
is there any chart? Is there an available chart anywhere that would tell a person like myself what size generator is needed for different appliances, air conditioners in the home?
Square footage.
That's a good question, and I'm going to say know your appliances and know your load, because I've seen so many charts that are way out of line with what can be found in the real world.
But for a novice like myself, to buy a generator, how big of a generator do I want to buy to run, say, just the lights, or to run the hot water heater and the lights, or to run the air conditioning and the lights, or to run the freezer and the refrigerator?
We're going to get into that some. Okay, question?
What are the dimensions on this particular thing? Like how much space would it take?
That particular generator is about
I'm sorry. I guess I didn't have the mic up to my mouth.
Yeah, it would sit on that brown table about, yeah. It would sit on that brown table, and it weighs, probably 1,500 pounds, somewhere in that ballpark, I'm going to say, somewhere in there. And yeah, like I say, that will run an entire house. You really don't have to worry unless you've got some additional load. And that's a typical, under 2,000 square foot house. You get into over 2,000 square feet where you need a second air conditioner or a 5-ton, a larger air conditioner, then, like I say, you may have to shed some load before you put on that 4th appliance.
I'm assuming that's an electric water heater, not a gas?
Electric water heater. Yeah, if you have gas water heater, then you don't even have to worry. That's 4,500 watts that you don't have to worry about. And that's the load of a typical water heater, is 4,500 watts.
What about, so in a disaster scenario where everything's off and then you're running one of those behemoths, what's your opinion on neighbors and other people knowing you're running that?
Is it noisy?
That generator is very quiet. It's a gasoline-powered lawnmower makes more noise than that generator. It's very quiet. It's got a large muffler inside that housing, is a large muffler, and the radiator fan is ducted as such. In fact, the only thing you really hear is the radiator fan. And it sounds kind of like a lawnmower, but I say a gasoline-powered lawnmower is actually louder than that.
How much is one of those?
Brand spanking new on the trailer, they're about 18 grand. Used, I bought that for $4,500 about 15 years ago or so. They're out. You can buy them from rental companies is the best place to get them. And yeah, $4,000 to $5,000 would probably be about what you're going to pay for a used one like that. That's just okay. This is a transfer switch. This is a manual transfer switch. This generator in the picture and the associated transfer switch is 100% manual. So you do have to have a little bit of know-how and savvy to hook it up and get it running. There are fully automatic generators. You can buy one installed, and the price starts somewhere around $25,000. They are out there. In fact, from what I understand, a lot of people in the northern part of the country where the snow is really deep and power goes out quite a bit, a lot of people do have them in their homes. And yeah, that's what I'm told the prices they're not cheap, but they are fully automatic. You do, as the homeowner, you do nothing. But they will require maintenance though, which means you do have to run it every now and then or pay a company to come out and maintain it for you, that sort of thing. You know, there's no such a thing as a generator that does not require maintenance, and that's the big downfall of generators, is the maintenance needed. This is a smaller propane. This happens to be propane. In fact, this guy is a dual fuel. This is a dual fuel. It'll run on gasoline and propane. I don't know if it'll run on natural gas or not, but it will run on gasoline or propane. I think it's a 6 kW. It will not run a 3-ton air conditioner. But he didn't want to run his air. This is brother in our ward here, and he doesn't want to run his air conditioning. His number one concern, like everybody, is the refrigerator and some essential lighting, some essential cooling. He has a piggyback evaporative cooler, and it'll run that no problem at all. And it'll run a lot of the house. And what he has, unlike this transfer switch where you notice it, I'll use my pointer here since I got a pointer. These lines here, this is the grid coming in off of the electric meter, and then this is the output to the distribution box here. And these white wires is the input from a plug on the side where the generator plugs into. And so as you see, you switch the entire house, everything with this transfer switch. This transfer switch, you have separate switches that you can take breakers, select breakers that you want to select, like your kitchen outlets, your refrigerator, freezer, of course, maybe your bathroom for a hairdryer, maybe your some kitchen outlets for you, because you can run your heavy kitchen appliances with this generator, waffle maker, electric skillet, microwave, any of those. And long-term usage, you can use these indefinitely as long as you have fuel for the generator. And hold that thought, because when we talk about inverters here, we're going to have some differences there. But with a generator, the advantage of the generator, you can cook breakfast, lunch, and dinner for the ward till the cows come home. As long as you have fuel, you will have electricity to run those appliances.
Now, if I have a gas stove, which is what I do have,
No problem. As long as the gas grid doesn't go down, you're set.
but it could.
If it does, then you've got your electric. I mean, as long as power's up, or you have a Jenny. Yeah. Go ahead, Darrell.
In my home and in many homes, we have natural gas that runs hot water heater, stove, and one's a refrigerator, I believe, also. Those do not require a generator. That's direct power to the appliance, right?
Your gas appliances, older gas appliances do not require any electricity. Some newer gas appliances do not have an old-fashioned mechanical flame pilot light. They have an electric igniter, and you do need a small amount of electricity for that igniter to run.
Okay, but what I'm saying is, can you hook up with the natural gas for the hot water heater, for the stove, or any other appliances, or any other equipment that you've got running with natural gas, can you alternate that with propane?
That depends on the appliance. Some appliances, and I believe most, I know all water heaters, I don't know of any exception, as well as ranges, will run on propane or natural gas. You adjust the air vent by the burner to switch it between propane and natural gas.
So if natural gas stops, you turn the gas off and switch it to propane.
You could switch it to propane if you had the propane and the plumbing available to do so, yes. Without a motor running. Yeah, the only way you need electricity is if actually if the gas valve is electric, and I believe some of them are, you need electricity just to turn the gas onto the device. If you don't need electricity to turn the gas onto the device, say the valve is mechanical and the electric is just an igniter, then you can light it with a match or whatever and don't need any electricity at all. Okay, and anyways, any questions on this little transfer switch where you take select circuits that you want from your house in lieu of the entire house, like this transfer switch? Any questions on that?
Now, he's not using any air conditioning on this.
Correct. He has a backup evaporative cooler that he'll use.
Have to get a second one to run the air conditioning? Or is it smarter just to buy a meter?
If you wanted to run your air conditioning also, go this route. And just put the whole house on it. And a three-ton air conditioner is going to take at least a minimum of a 9-kilowatt generator to start it. That's the problem with air conditioners, is typically 3 times the run power is required for only a fraction of a second, but to start it. Notice how sometimes when the air conditioner comes on, the lights dim for that little, that's the power that the compressor is running on the start winding. And it's typically 3 times the run power, so go ahead.
Is 3 tons a typical for a house? Because I believe I have 2 1-ton.
In Arizona, the rule of thumb is 1 ton, and 1 ton's 12,000 BTUs, 1 ton for every 500 square feet is the basic rule of thumb in Arizona. In the let me say in the valley, for the climate, summertime climate in the valley. 1 ton for every 500 square feet.
So for a 2, probably have 2 tons, 2 tons.
So a typical single-story single-story residential structure around here typically is between 1,200 and 2,000 square feet. Is your typical, average middle-class tract home. Typically between 1,200 and 2,000 square feet.
So if I have a 2-ton air conditioner, because my mom has a single story and she has 1 unit, and I have 2 stories, but I have a few story units.
Mm-hmm.
I'd like to try and run one of those off of the generator. So would that mean I would need on 2 tons, how much electricity per ton?
That's a good question. For round numbers, it's about a kilowatt a ton. 1,000 watts a ton is a round, rough ballpark figure. And it varies. The outside temperature and the inside temperature will vary the load. There are many variables that vary the load on an air conditioner. And even at that, the 1 kilowatt per ton, it's still just a round, rough ballpark number.
And then I would need twice of that just to start.
About 3 times that to start it. Yeah. A 3 kilowatt generator, a 3,000 watt generator. I've seen lots of those start 1-ton air conditioners. A 2 will not start it. A 3 will. A 4 or 5 definitely will. And that's, of course, with no other load on it. Until the air conditioner's running, then you can add additional load.
Now, I read online that the sine wave that a generator, the square sine wave that a generator produces, and the compressor and the electronics in the air conditioners, they don't like the square wave. They prefer the more pure sine wave. What do you know about
Okay,
that?
mechanical generators produce a sine wave. We'll talk about square wave when we talk about inverters. But yeah, mechanical generators, just due to the mechanical nature, produces a sine wave. So no issue there at all. So any more questions on this? Okay, and here's a little tiny little generator here. I think that's a 2 kW. Does it say on it what it is? I think it's a 2 kW. The Honda there is actually it's a DC generator that drives a pure sine wave inverter, and the other one next to it should be one that's just a mechanical generator. Mechanical generators have to turn at the alternating current frequency, which is 60 cycles per second, or 3,600 RPM. You can add what are called poles to the generator, and I won't go into that, so they can turn at a lower RPM. Typical generator RPM is 1,800 or 3,600. And that produces a pure sine wave. The little Honda guy there, because it's a DC generator that powers an inverter, it has some smarts in it. So as the load decreases, the engine RPM will decrease and thus save a lot of fuel. They are far more fuel efficient than the one that sits there, far more fuel efficient with a light load on it than the other generator with a light load on it. Heavy load, they're going to be about the same, but a light load, you'll see the fuel savings. Okay, now we're going to get into, go ahead, another question?
What exactly is a light load versus a heavy load? Is it air conditioner?
Oh no, let's say light load, let's say 10 to 20, 25% of the capacity of the generator is a light load.
Sorry.
So in other words, that 2 kilowatt guy, if you plug 300 watts into it, that's a light load. And it's just you'll hear the engine go down to low idle. You plug a crock pot in it. Typical crock pot's 250, 300 watts. Plug a crock pot in it and that motor's just gonna run above idle. You put a hairdryer on it, turn a hairdryer on, it's gonna go to full output. Because a hairdryer is typically 12 to 1800 watts, depending on the make and model of hairdryer. And that's why it's important to know the load on your appliances. And there's hardly an appliance out there that doesn't have a nomenclature tag of some sort on it that'll say volts in either amps and or watts. And sometimes they'll throw you for a loop and they'll have a figure on there that's called VA, which stands for volt amps. And basically just calculate that as watts, or like do your arithmetic as if the VA figure was watts. We won't get into the theory behind that here. The portable generator, of course, most likely you're going to set it up by your front door in your driveway and run extension cords into your house. And they will power, the basic appliances there that we're talking about. One thing about generators and light loads, and especially, we're not going to throw that little Honda guy into this, but we're going to throw all the other generators in there and light loads. Generators with light loads on them make noise, burn fuel, and cause unnecessary grief a lot of times. So depending on your load, and that's why I want a lot of questions and answers here. When we get into the inverters here, we're going to talk around where you talk about, are you better off with a generator or better off with an inverter? And let's see. Yeah, we'll talk about extension cords. Let's talk about extension cords. Let's talk about extension cords. Now, we'll get into that with inverters also, but the fact that we're focusing on refrigerators and extension cords. Here's a little horror story of a family in our ward some years ago. Their power went out. Their underground feeder, the Salt River Project feeder that went under the ground to their meter, failed. And they were without power. And the whole rest of the neighborhood had power. So it wasn't an outage, it was just out to their home. And Salt River Project was going to take about 3 days to get around to fixing it. And so their concern was their refrigerator. And so a very kind, caring, helpful neighbor told them that they could run an extension cord over to their carport outlet and plug their refrigerator into that. So they got out a couple of 100 feet of extension cord, 16 gauge wire, we'll talk about that in a little bit, and they plugged it into the carport outlet, and they went and they plugged it into the freezer, and they walked away from it. Everything went bad. Plus the refrigerator was destroyed. What had happened was the length of the extension cord, plus who knows the wiring in the house that it was plugged into, like if it was a carport outlet and the distribution panel was on the other side of the house, you've already got probably 100 feet of wire, and if it was a 15 amp circuit, 14 gauge, a lighter gauge wire. So you're probably looking at well over 200 feet of run with a smaller gauge wire. And then every time you daisy chain outlets, there's a little bit of resistance, especially the cheap outlets that the tract homes come, where you push the wire into the outlet, not wrap it around the screw and tighten it. There's resistance in there, and all that resistance is like a long, go back to the picture of the water hose, the long hose, when you're trying to flow that water, the pressure drops and drops and drops. Same thing with electricity. They plugged in that refrigerator, and the compressor starter winding was there. It drew enough current, or not enough current to trip the breaker, but enough current that the motor wouldn't turn, the compressor wouldn't turn, and it burned out the starter winding in the compressor. All they would have had to done is listen to it to make sure it was running. They didn't do that. Or be a little bit electrically savvy and think about wire gauge and where we're going to plug that in, especially a long run from a neighbor's house. Call somebody that knows a little something about it if you have any questions and something like that happens, because they wound up having to replace the refrigerator. And plus its contents was all destroyed, and the smelly mess that produced. Questions on that? Something else with extension cords too is, look under the table when you get a chance, in those Home Depot store-bought molded extension cords. Those plastic ends, they're not the best things in the world, especially if you put a load on one. A lengthy load, like plug a heater into it for a long period of time. They get hot, they'll melt. The tension of the female socket will lessen, thus it won't mate with the other end as well, and that becomes resistive. Where there's resistance, it's like a kink in the hose. When you're trying to flow water or flow current, the pressure, the voltage drops, and they get hot. And if you want real reliable extension cords, buy the wire at Home Depot and buy the higher dollar ends and make your own cords. You won't have that issue. And I'm going a little bit overboard with this, but that's my philosophy on that. And especially, you're going to run a skill saw and cut some wood with a skill saw for a few seconds here and there, no problem. The store-bought ones are fine. But to run that electric heater or something where you've got a big load on it for a long period of time, that's where you run into problems with those molded ends. Even the cheaper wall outlets, they will heat up and they'll fail also. They won't start a fire, but they will get resistive and they will cause issues like I just described about the refrigerator. Questions? Go ahead.
So with the extension cords, they come in different
Gauges and lengths, yes.
So what would an industrial, you're talking about a 16, I imagine that's just a kind of an all-purpose gauge?
Yeah, like that green cord there, that's a 16 gauge.
Okay, so is there an industrial gauge?
12 gauge is the 12 gauge is the real heavy duty one. Is 12 gauge. You can even get 10 gauge for the long run with the big load, especially the construction worker that's going to run a a worm gear skill saw or a chop saw or a 120 volt portable wire feed welder, because some of those devices will the current to them is in upwards of 30 amps for short periods of time while they're on their heavier loads. And a long, a good 100-foot run like that, yeah, you want a big heavy-duty cable for that to carry that load.
And do that when you go to the store. Does the tag say what the load is on it?
Not what the load is, but it'll say the gauge of it. You can
Okay.
you can just follow along the cord somewhere on the outer jacket, and you'll see like 14 AWG. That means it's a 14 gauge wire. And 16 gauge wire is good for about up to 10 amps. And this is this is talking like a 50-foot, not much more than a 50-foot run.
Okay.
And 14 gauge is good to 15 amps, 12 gauge is good to over 20 amps, 10 gauge is good to over 30 amps. Or each time that run increases, say once you're in that 50, 60-foot ballpark, when you double that length, go up a gauge also, go up a wire gauge. Yeah, go to the smaller number, the bigger gauge. Yeah, there you go.
This is the gauge you've got right here is probably a 4 or 6.
This is 1/0, I think. It's been so long to put this together. What is it? Oh. 1/0, yeah. So that's big. We'll talk about battery cable and this stuff for the DC stuff here in a little bit. Okay, questions? Okay?
So, of these two generators, is the Honda superior?
Yes.
Okay.
As far as cost and as far as fuel efficiency, it is superior. As far as being a generator and able to do the job, they're both equal.
Okay.
Okay, let's talk about inverters, one of my favorite subjects here. Because this is my personal opinion, everybody needs inverters. Even if you have a generator, you still need inverters. Because inverters, number one, require no maintenance whatsoever. None. Put it on the shelf and forget about it until you need it, and it'll work. First time, every time. Unless you hook it up backwards or do something like that to damage it. No maintenance required whatsoever. They can also be permanently installed in a vehicle. A little bit of effort to do that. They actually, for heavy loads, for big inverters at heavy loads, you're ahead to install it in the vehicle because the voltage drop is less from the permanent eyelet connection to the battery or solenoid or wherever than there is in these clips. But for versatility, so you can use it with any vehicle you have, then keep it portable with clips. Daryl.
Tell us what an inverter does.
An inverter converts DC to AC. And that's just an electrical term that has been around a long time. A converter, which we won't even talk about today, a converter converts AC to DC. Like the power supply for your computer, or if you're a ham operator, your power supplies for a lot of your radios, they're converters by definition. We're not even going to go there. We're going to talk about just inverters here. Also, for anyone, and we're not going to go into it, but for anyone that has it's hard heavy. If you have the EMP phobia, that you're really scared to death of the big EMP and it's going to wipe out all of your electrics, EMP can damage an inverter, but they cannot damage these dynamotors. This is old school inverter. Before they had inverters, they had dynamotors. And all it is, it's a DC motor. It's a shaft with two windings connected to it. One end is a DC motor, the other end is an AC generator. And this one will generate up to 500 watts. Back when I was going into the land mobile business, the two-way business, commercial two-way business 45 years ago, and doing a lot of mobile radio installs out in the field, as well as going to some tower sites where grid power was not plentiful or easy to get to. I carried my own power with me to run soldering irons, drills, lights, test equipment, that sort of thing. and this is a little goodie that I took. And I even like to cook lunch when I go to some of these sites or projects. I love to cook hamburgers. And I got myself a little 450 watt Presto burger cooker. Put the patty in it, squeeze it together, plug it in, and away you go. I still do that today, but I got a George Foreman cooker and I use an inverter. But something that I always get a laugh at, and most of my colleagues, so I tell the story, I'm well known for that. Anyway.
The basic question is, what does AC run? What kind of appliances does AC run?
That's a good question. Alternating current is required for any induction motor, and that's a motor without brushes, or anything that uses a transformer for the most part.
Most people would want to know what appliances are run by AC power.
Oh, appliances, okay. All of your, just about any fan, refrigerators, freezers, of course, most electronic equipment, some power tools, just about all air compressors and equipment like that. What am I leaving out here? Yeah, anything with an induction motor in it, or a motor that doesn't have brushes. And an easy way to tell on an appliance if a motor has brushes or not, quite often you can see the little brush access caps on the side of it, but by the sound. When you put a load on a universal motor that has brushes, the more you load the motor slows down. A induction motor, the more you load the motor, you don't hear it slow down. It won't slow down until you've loaded it to the point of its failure. You'll hear it grunt and maybe, use more current. You'll hear it grunt and work a little harder, but they don't slow down. Anything that
anything with a battery would be DC.
Yeah, batteries are DC.
And so anything that has an AC adapter like a wall wart would then be DC.
That is correct.
So
right, but that wall wart, if it's a transformer, it needs AC. The wall wart will not run on DC. If it's a switch mode device, they don't tell you this, but they will run on AC or DC. Oh, go check into the net. Check me in too. Okay, so let's talk about power and watts and everything again, because this is where it's going to get kind of critical here with inverters. A typical automobile, car, light pickup truck, typical automobile, just about anything made since 1990. To get that maximum output of that alternator. So we're going to talk about, plus not only the RPM needed, once you load those alternators over 75% of their rated output, they will eventually fail. The diode will eventually go. It might take days, it might take weeks, it might take months, but eventually you're going to pop a diode on it. If you keep the load down below that 70-75% ballpark, typically diodes and stuff, they'll run forever. And also with the engine at low idle, most automobiles with the engine running at low idle, those alternators will produce about 70-75% of their capacity, or about a kilowatt, about 1,000 watts or so. But these cars have computers in them. These cars have electric fuel pumps in them, and the ignition system in them. And if the engine runs for a long period of time, the electric radiator fan is going to cycle on and off, on and off, on and off over time. So with everything, all the appliances, all the lights, everything in the car off, except for the engine running and the essential electricity to run and run the engine, keep it cool, you've got about 800 watts available that you can use outside of the vehicle. Or in other words, to connect an inverter to it, run some cords into your house, and you've got approximately 800 watts continuously available to you. Does that make sense? Any questions?
So how many watts would you need to start up a refrigerator?
Good question. Typical refrigerator is about 200 watts running, so about 600 watts to start it. Any 1,000 watt inverter will start and run a refrigerator. And when I say start it, I mean no other load on the inverter until the refrigerator is running, then you can put additional load on the inverter. Like this guy here, he's a 600 watter. He's not going to run a refrigerator. It would run the refrigerator if you could get it started, but it doesn't have the oompah to start it. The big guy, the 2,500 watt here, no problem. I recommend a 1,500 watt inverter. If you're going to use an inverter for what we're talking about here, get a bare bones minimum of 1,000 watt and ideally a 1,500 or larger inverter. The larger the inverter you get, the more appliances you can run short term, big load short term. And that is because that alternator is capable of about 800 watts continuous. You've got a battery there. It's like a toilet with the tank full. So you can put a larger, much larger load. You could put the 2,500 watt inverter on it and run a 2,500 watt load for a matter of a few seconds, couple of minutes, depending on what the load, because you're discharging the battery as you're running that bigger load. And then when that load is removed, as long as you're not at the alternator's capacity at that engine RPM, you will charge the battery back up. So you can plug a crock pot in, 250 watts. You can plug in some essential lighting, especially if they're CFL or LED lights. This is where energy efficiency comes into to play. It can do you some damage here. We'll touch on that briefly before I'm done. But for the most part, don't worry about that. And, you can keep your load down to 400 or 500 watts. Cooking something in a crock pot, essential lighting, a computer going, and if you're a ham operator, you can be on the radio. And the kids can have their little tablets or whatever for entertainment. That's all low wattage stuff. And you can sit out there and your car engine just running at low idle. That particular car is a 4-cylinder engine. At low idle, that engine will burn about 1 gallon of gasoline every 3 hours that it runs. A V6, 1 gallon of gasoline every 2 hours. And I measured with my Tahoe with a medium-sized V8, about 50 minutes. Almost an hour on a gallon of gasoline. Sitting there at idle with that 700 watt thereabouts load on it.
So where is the market for this inverter and the other? I mean, where do we go?
Harbor Freight's a good source.
Really?
Yeah, you can buy them online, Harbor Freight. And when I first saw Harbor Freight, because Harbor Freight is cheap Chinese junk, a lot of stuff. You gotta watch what you buy there, because some of their stuff is garbage. Use it once and throw it away. Some of their stuff isn't half bad. And a couple of my littler inverters, and I use quite a bit, they're Harbor Freight specials, and I know people now, and they've been around long enough, I know several people that have larger inverters from Harbor Freight. I haven't heard of any problems. So I'm going to say go with them. If you have a problem, I'd like to know about it.
Because I saw the Honda at Sportsman's Warehouse,
Mm-hmm.
but I don't know
Honda generator, you mean?
Yes. Not
Okay,
the
because we're talking
inverter.
about inverters right
Yeah,
now, so
yeah.
not to confuse it.
So
Oh yeah, the generators. Yeah, do not get a generator at Harbor Freight. Garbage. I've never heard of one success story yet with a generator from Harbor Freight. Inverters, yeah, I would. I've got a couple smaller ones of my own. No problem there.
So what is the approximate cost?
For the inverters?
Yes.
1,000 watt is going to be, last time I was in a Harbor Freight, about, I think it was like $80 for 1,000 watt or something like that. And I think they're 25. They had a 2,500, 2,000 or 2,500. It was like 150, 170, somewhere in that ballpark. Changed back from 200.
So inverters, not, what's the other one we're talking? Generators.
Not right. Right. And these inverters, let's touch on this topic for a little bit here. Now, these inverters are what are called square wave or modified sine wave inverters. You can get what's called a pure sine wave inverter. Typically, for the same wattage, you're going to pay twice the money. To run your typical lighting equipment, your heating equipment, any motor with brushes, and even most induction motors, you're not going to have any trouble at all. Some induction motors will run a little bit slower on the square wave. Electronic devices, especially sound producing, sound audio amplifier devices, you may hear a little buzzing sound out of the speaker on that sine wave, depending on the characteristics of the amplifier and its power supply. It will not damage them, but you might have that little obnoxious buzz. Some higher end electronic equipment, especially laboratory type equipment, you want a pure sine wave. So
if you're starting a refrigerator, what is the typical watts to start at? You said 1,000 watt?
About 600.
600
for a fraction of a second.
Okay. So if you had a, I see that you've got 800 available watts now, but let's say that you're running a load that's a little bit more than that. Would that just draw from the battery for the
Yes.
temporary? So if you had extra batteries, then you could you could draw from that from your larger loads?
Yes, until you ran out of battery, yes.
But for a startup, then...
For a startup, or parallel two vehicles together. You
Gotcha.
can always do that. Just jumper cables, good quality. And I mean, don't buy the cheap store-bought ones. Build your own with welding cable, or buy them. They'll be high dollar, because I mean it cost me $50 for the materials to build 25-foot long jumper cables with welding cable. But money well spent. They will not fail you. And Phoenix Welding down here on Baseline has all that stuff. Get the high-end, real heavy-duty spring-loaded clips, because you need a good, tight clamp. And there's still voltage drop in that for your heavier loads. That's why I say if you're going to use it for heavy loads all the time, you're ahead to permanently install it in like in a pickup truck behind the seat, or in the toolbox in the bed, or something like that. And then use the appropriate wire gauge for its maximum load, of course, when you wire the thing up.
Can you explain that, spin it around?
Oh, sure. This is the inverter in the picture there with Shannon hooking it up. This is the same one. I think I got 10 feet on this one. I can't remember. I've had it for 20 some odd years. But anyways, just positive and negative, clip to a battery, just like you're going to jump start another vehicle. No difference whatsoever. Make sure they're gouged into the posts as good as you can, because like I say, you want the best connection possible if you're going to have a heavy load. And heavy load for an inverter, anything over about 500 watts is considered a pretty heavy load as far as the DC current that's going to flow through the DC wiring here. And then this particular inverter was one that was made to be installed in a industrial vehicle and wired into a distribution system. So I had to build my own outlets here for it, just a quad box and two outlets on it there. And I have, back when this was new, I running my truck, and I had an aftermarket 200 amp alternator and a fast idle on it, and I ran it up and I did a load of wash in a top loading washing machine, and I cooked a TV dinner in a microwave oven at the same 1500 watt microwave oven at the same time, and ran just great.
I just looked up on the Harbor Freight website, and they've got 1500 watt continuous 3000 watt peak inverter, $129.
Wow, okay.
So right in that range.
Yeah, there you go. Don't know.
They have a coupon.
Oh, okay. I've never shopped at
Use the coupon.
There you go. Or just get online, check Amazon and the typical online places and all that. Even I'd look on eBay and Craigslist for a used one, and this is only if you're going to go something real big, because the money it costs for a smaller one, you might as well buy a new one. But for a good size used one, eBay, Craigslist, they're good sources. Try it before you buy it, though. Meet up with the guy or make sure that it's got a guarantee on it, it's going to work, or make absolute sure on that if you're investing several $100s. Like you bought a pure sine wave one, and that probably set you back a few hundred.
Yeah, it was a combination battery charger, inverter, generator input. It came out of an RV, and I got it from an RV salvage. Typically, that was $2,000. I got it for $750.
Mm-hmm.
So
see, something like that you want to guarantee if you're buying it used. For that, okay. Let's see. Did we leave anything out?
Are there different brands that are better?
I don't think so.
Okay.
I don't think so. There, like I say, there used to be, I don't know what today, but not too many years ago, there were only a couple of manufacturers out there that manufactured them, and everybody bought that brand or bought those and put their own name on them. They'd have contracts with that manufacturer, we'll buy this many, we put our name on it, sort of thing. So yeah, this one actually is an Astron, has the brand name on it, but I know it's made by Stat Power, which is one of the first makers out there. And Astron just put their name on the Stat Power device. Different sizes here. This little guy here is 400 water. This will run a crock pot. This will run a computer. This will run essential lighting. This will run a curling iron. It'll run a Dremel tool. Little appliances like that. Again, look at your appliance and see it's a 400 water. So if the appliance is 400 watts or less, it'll run it. And this little guy here is, I think, 80 watts. It's good for like charging up a laptop computer, or as a ham operator, some of the smaller needs that we have in the for our radio stuff. I use this particular one for some of my test equipment, because I do a lot in my radio profession. I do a lot of field work with test equipment, and I use this to run test equipment. Okay, let's see. Let's move on. Okay. Oh.
is it a good idea to run a crock pot off of an inverter like that? Wouldn't that take a really long time draw versus just like throw in the microwave, or use a different appliance besides a crock pot?
I just throw crock pot out there because the wattage is such that
Okay.
let me say this, a crock pot, or the type of a load that a crock pot is, which is about 250 to 300 watts depending on make and model.
Kind of like a heat plate, or those grills, those electric
Now
grills?
those are a lot higher wattage there.
Okay.
Yeah, a typical hot plate's about a kilowatt. Anything between 1,000 and 1,500 watts. A microwave oven, anything, the little teeny tiny little tabletop guys, they're 700-800 watts. The larger residential ones, they're 1,500, 1,600, 1,700 watts. So again, look at the nomenclature tag. They all have it. It'll say volts and either amps and or watts. The best power supply on the road is a hybrid vehicle. And what makes them so fantastic compared to a conventional vehicle, if you're going to use it as a power supply, is it doesn't get any more fuel efficient than a hybrid vehicle. A typical hybrid vehicle has a large high voltage, the Prius, it's 250 volts charged and about 175 volts discharged DC battery, which powers the car, the locomotion of the car, as well as the large appliances in the car, like the air conditioning. And then it also has a DC to DC converter that will drop the 200 volts down to 14 volts, and it also has a conventional automotive battery in the trunk. Prius has it in the trunk, and the different hybrids will have it their various places, but they will have a 12-volt system. So the beauty of the hybrid vehicle is with the power button on the car pushed, so the car is powered up, turn all the 12-volt devices off, and you now have 14 volts available at the battery, and the power supply that powers that will, they're 100, 110 or 120 amp power supply. So you have all that current available at 14 volts off of the big battery. And when the big battery is discharged, the engine automatically starts, charges the big battery back up, and shuts off, and just repeats the cycle over and over and over and over again. And with those larger loads, they're more fuel efficient than those little generators even. 1 gallon of gas. In fact, I do Pioneer Day up in Cedar Valley, Utah every year, and my friend up there, we do the audio for the rodeo grounds up there for the Pioneer Day rodeo, and it's a 300-watt public address system. And so we take the Prius up there, and using that Anderson power pole connector in it to that inverter, 1,000-watt inverter, we plug the sound system and the essential lighting. There's computers that they use up in the sound booth up there at the rodeo grounds. We plug it in with an extension cord, lock up the car, walk away from it, and it just runs there for all afternoon and all evening while they do their thing. And typically burns 1 gallon of gasoline for 8 to 9 hours, and that load on it. So, and just think about that for emergency communications for your house, that sort of thing. I'm not a big fan of hybrid vehicles for transportation, but for the best, no, that's not mine. I got the picture off the internet.
Oh, okay.
No, and this one, the trunk, this is my friend up in Utah, just to show the connectors. And I was going to touch on that at the end, but we might as well hit it now. Anderson power pole connectors. For ham radio operators, you know what I'm talking about. If you're not a ham operator, but you're interested in using 12-volt DC appliances, they're the best darn electrical connector out there for DC voltages. The reason they're so good is they're easy to put together. They are sexless, so you can make extension cords. It doesn't matter which end of the cord you plug in because they are sexless, if that makes sense how the design of it is. Anderson power pole. And that's just showing that. In fact, the little inverter, that's this guy here, with just a smaller power pole connector because it's a smaller load. And also with the hybrid vehicle, because it is 14 volts at all times, as long as the car is turned on, you can charge a battery with it. And the same thing, it charges off the big battery. When it runs down, the engine starts, and there you go. So makes a nice battery charger. You can do the same with a conventional vehicle, but you have to run the engine. Otherwise, the voltage will be only 12.5 or whatever the battery voltage is. You're not going to charge the battery till you've got it up with the engine running. And with the hybrid vehicle, you've got that engine running voltage at all times, whether the engine's running or not. Any motor vehicle. I see these things out there with these little rubber things on them, and they move, and you can sit in them and ride in them and drive them and all that kind of stuff. Some people call them vehicles. I call them power supplies. If it's got an electrical system, if you think outside the box, especially in an emergency, you've got power. You've got power. Any motor vehicle, any vehicle. That tractor has a 12-volt system and a 60-amp alternator on it. Originally, it had a 30-amp generator. It's been modified. Don't even need the load. But that tractor, in fact, the way that tractor is geared, the way the alternator is geared on it, it makes its full output at low idle. on it. So, a good source. Especially, a lot of this is geared more towards ham radio operators being able to run their radios on anything. But heck, if you can run a radio on it, you can run a lot of other appliances and devices on it, depending on the load and the length of time you're going to be running that load, weighed against the generation and storage capacity of what you're plugging it into, which is kind of explained there. That little lawn tractor has a 15 amp generator in it, 15 amps. 15 amps. That's over 200 watts right there, with the engine spooled up a little bit. Or off the battery, it's a 35 amp hour battery in there. So for a ham operator, you can plug a typical radio on that, be on the air for hours on end just off the battery. For someone who wants to use it for an appliance of some sort, you could run an electric drill, a cutoff wheel grinder, a Dremel tool, any of those appliances that have that produce that electrical load is up to several hundred watts, even up to 1,000 watts. Up to that momentarily, a few seconds, no more than a few seconds, couple of minutes, and you could run it with that if you had a need to for that type of appliance.
Question.
Go ahead.
So when you got batteries and you're talking about, running out the battery, how long does it take to charge batteries, like per amp hour or stuff like that?
That depends on what you have to charge it with. That lawn tractor, it's only a 15 amp generator on it, and the engine has to be spooled up to do it. And that battery is a 35 amp hour battery, so it's more involved than this, but round ballpark figure, couple hours to charge the battery up.
Okay. Is there what
on that one? Now,
what's the calculation per amps in to charge?
Pretty much figure just do it this way: the amp hour capacity of the battery and the actual current available. So in other words, if the battery is a 35 amp hour battery, I'll say this, but it's not correct, and I'll get into why. You can charge 35 amps for 1 hour. That's not really correct. If you charge a battery too fast, it actually takes longer than that time period to charge. And you'll see battery specs, and I don't really want to go into it here, but you'll see this many amp hours at this hour rate. And that's mainly for discharge, but it still works the other way for charging on most batteries. Some batteries are designed they can only be charged at a slow rate. So again, it depends on the type of battery. And what I'm talking about with this presentation is your typical automotive battery, or your typical, and ideally your typical deep cycle, like your automotive AGM or wet cell deep cycle battery.
Like a golf cart kind of battery?
Well, that's a separate, those are 6-volt and separate packages, but yeah, they are deep cycle.
Mm-hmm.
Yeah, they call them RV and trolling motor batteries for 12 volts.
Okay.
And even, and that's the other thing too, your typical automotive cranking battery, they're not designed to be deeply discharged multiple times. They're good for a few cycles, but you give them more than a handful, there's no set number out there, but a handful is a good figure of deep cycles, and it's going to fail on you. Slight discharge and back up, then you're good. And that's why, like with the motor vehicle, with the inverter and the continuous load that is less than what the alternator can provide, so the battery stays charged, and the occasional toast in the toaster, nuke something for 3 minutes, something like that, that discharges that battery minimal. Like starting the engine with the starter motor, or leaving the lights on for 10 minutes or whatever, which is a slight discharge. Okay, I'm about done, I think. Here, let's see. Just power pole connectors. If you really want to get, if you really want to be an electrical geek like me, you can get little devices that'll plug into your 12-volt system. It'll show you the voltage, the current, the watt hours, the amp hours, and all that information that a true geek wants to know for out in the real world to be practical. If you know your appliances, You really don't need it. It's frills. But if you like that sort of thing, there you go. And then let's just touch on solar here a little bit with a battery. There's grid tie solar. There's outfits out there all over the place trying to sell you that. Or you can do your own and solar with a battery. And again, what you can run on it, 12 volts DC or with an inverter to 120 volts AC, however much capacity you have in batteries combined with however much generation capacity you have in your solar cells is what you're going to be able to run. You just have to do the arithmetic to figure that out.
So can you line all these things up? You can have a solar power panel hooked into your battery with an inverter coming out the other end, and okay.
Yep, absolutely.
Okay.
Absolutely. In fact, that's what I have at my house, and I mainly use it for ham radio gear. But I also have a 1 kilowatt inverter, and I also keep this dynamotor sitting right next to those batteries there, so I can get 500 watts off of that. And then in my radio room, I have a 1,000 watt inverter also that'll run. So we're set. Plus, I have a generator, so we're covered.
I still need two things now. One, I need to have Doug Pelley produce a chart of generators and what size and what power they put out to produce enough to run different appliances. Number two, I need to know what appliances need AC and what equipment needs DC.
Hey, Doug.
Yeah.
Those are two charts that would be very beneficial.
On Amazon.com, if you go and say, I want to buy a generator, there is a generator buying guide, and it has a form that will allow you to fill out to calculate what size of a generator that you need.
There you
and
go.
you can select all kinds of different appliances and what have you. So that's a good one. You said that many of them are not accurate,
Some of
but at
them
least
are
should get you in the
not,
ballpark.
But they'll all get you in the ballpark.
Yeah.
That is correct. That is correct. And I'm Amazon.
That tells you what the generator, what size generator you want to buy. I don't know that until I know what appliances require.
Well, so you do it the other way. You put in what appliances you have, and it tells you what kind of generator you want. So you get to decide.
I can tell you off the top of my head what most appliances use.
I'm not doing Pelley.
Oh.
You need to have a chart to look at to know.
I'm not much for drafting a chart. I could tell you. Call me up on the
And
phone.
also what appliances you need for AC and for DC.
Everything you're going to use is AC except for your ham radio gear.
Okay.
Just figure everything's AC.
Thanks,
Unless
John.
you're dealing with radio equipment or motor vehicle equipment.
Okay, well, those are two charts I'm going to be trying to
Okay,
find
we'll
someday.
talk about that at lunch. Okay, I think we're done.
There's another chart that you get is Alt-E. I think it's alте.com. They're a solar provider, and they have a huge database of power. They seem to run a little bit high. When I went with my kilowatt to all my computer equipment, and they seem to be a little bit high, but I think they're also including monitors and printers and all sorts of stuff. So they have a pretty good database
And some of
as
those
well.
charts will go with the maximum possible, and yet in the real world it's not there. And also, and sometimes that maximum possible is like a compressor and it's starting, like we talked about, a starting power for a compressor as maximum load, or a power tool at its maximum load, and not mention lightly load. So that's why I like to, what are you running and what are you going to be using it for, and that sort of thing, and you get a better figure for that. Anyways, I'll turn it back to John. We're done.